Hello class, this is a video tutorial on sketching polynomials for extension 1 students. Now, some polynomials may require some long division in order to factor first, and then we sketch it. So remember that we're actually going to be dividing by something of x minus a, where a is any factor, not any factor, some factors of the constant term. You can pause the video and try and start testing values yourself. But I know that if you substitute x equals -1, we get 0. So the first factor we're going to use is by -1. Taking the coefficients of these, 1, -1, -5, -3. Ignoring the first, multiplying, adding, multiplying, adding, multiplying, and then adding, and we get 0. So that is a perfect factor, so we can factor y into become x plus 1. And since this is 3, this is now 1 degree less, so x squared minus 2x minus 3. And we can easily, or more easily, factor this because it's a cubic. And I can think of the numbers x plus 1, x minus 3, which we can simplify even further as x plus 1 squared, x minus 3. And then that there we can sketch. So we have x-intercepts at -1 and +3, and since this is a repeated root, we know it is a point, turning point at that x-intercept. Using the other characteristics of our polynomials, this is a degree 3 in total, and it has a positive coefficient. So it's going to start here, end here. So I can already see what the graph would somewhat look like. It should look something like, let's try and, oops. That's pretty neat, if I say so myself. And obviously, with you using a pencil, yeah, you may have to be a little bit more gentle in sketching these. So we first factor using long division, and we sketch it. For our next one, you can pause the video and try and factor it yourself. Just to save you the time, I already know that we're going to factorize into this. So just to demonstrate the first factorization, you might try, say, 1 and -1. You substitute x equals 1 or -1 into these, it doesn't work. But when you finally substitute -2, that would work. So taking the coefficients, 1, -4, -12, 32, and 64, ignoring the first, multiplying these two, adding, multiplying these two, and then adding, multiplying, adding, multiplying, and then adding. So this will first factor into x plus 2, x cubed minus 6x squared plus 32x. Oh no, sorry, just plus 32, not 32x, because that's x cubed, x squared, x, then the constant, so it's just 32. If you try and factor this again, you can test +4, which is what I'll demonstrate now. Let's use +4, and we're going to be factoring this here. So this will give us 1 minus 6. Oh, I and I'm missing, so minus 6. We're missing the 0x, so we still need that 0 there, and then 32. Ignoring the first, multiplying, adding, multiplying, -8, adding, multiplying, and then adding. So y can now be written as x plus 2, x minus 4, x squared minus 2x minus 8, and that we can factor as a quadratic. And that's going to be positive 2 and negative 4. And as you can see, we can make all of this because we have the same root here and the same root again here. So that is this, which is what we were aiming for to begin with. This is now a quartic, degree 4. So it should start here and here because we know it's positive coefficient, and it has x-intercepts at -2 and positive 4. And since they are repeating roots, they are also turning points. So it should be somewhat like this. Oh, come on, iPad. There we go. And there we have it. Now at this point, I'm sure you get the general idea where you need to just do a long division first and eventually factor as much as you can. And then from there, using repeated roots, as well as the general shape of quadratics, cubics, quartics, quintics, etc., you sketch the polynomial. Now at this point, I'm going to be doing 2 more examples. These are degree 5. Degree 5. We normally don't get this high up when it comes to degrees of polynomials, but at this point you can try it yourself. So this is going to be a rather long video. You can stop at any point you like or fast forward to the end. So here we go. Let's grab one of these. And here we go. In actual fact, if you take a look, they're all x's. That means you can already factor out x squared. This leaves us with x cubed plus 5x squared plus 2x minus 8. So we only really need to factor this here. For the sake of time, you could trial and error different values of x. Try 1, -1, 2, -2, so long as it's a factor of -8. But just to save time, I know it's going to be +1 that's going to work. So let's do a long division with +1. 1, 5, 2, -8. Ignoring the first, multiplying, adding, multiplying, adding, multiplying, and then adding again. So this will leave us with y is equal to x squared, x minus 1, x cubed, so this will be x squared, plus 6x plus 8. And that there, I can see we can factor into +2 and +4. And then from there, we can sketch the polynomial. We have x-intercepts at 0, 1, -2, -4. So 0, 1, -2, 2, 3, 4, -4. This is a quintic. It's degree 5. That means it, like a cubic, starts here, ends here, And we know this because it has a positive coefficient. It has a repeating root at 0, so it should either be like this or like this at 0. So let's take a look at what it will look like. So between -2 and -4, there's a turning point, so it should already be something like this. And then we're coming up to the 0. So rather than become an x-intercept, so it doesn't go through like this, it is a turning point at 0. So it should be, oh, that's kind of new. It's very close. Let's actually just do this by hand. So like this. And then, let's see if I can make it do it. There we go. Let's see if I can. It should be something like that. And then turns back around. This is, I definitely do not know if this is accurate or not, because as I've said before, we don't know how high up these actually go. It might actually be all the way up like this or much more shallow. I don't know exactly, but this is the general shape of this polynomial. Let's mark in all of the x-intercepts. -4, -2, 0, 1. Let's do one last one. This one, we definitely do need to do lots of long divisions. I'm going to save you the trouble and show you what you should factor into. So what that would look like, so you can do a whole bunch of long division, but we end up with this. So let's take a look at what this would look like. It's degree 5 with a positive coefficient, so it should start here, end here. It has x-intercepts at -2 and +2, but also at the same time it has a cubic here. That means it has a horizontal point of inflection at -2, so it should do something like this. And it has a repeated root at +2, so it should do something like this. Hopefully you can see the shape of this quintic being formed. All in all, it should look something like this, I believe. Very interesting shape. So graphing that in, this is -2, +2. Let's force it to do it. There we go. Getting that shape correct. Something like that. You can type this all into Desmos or GeoGebra, whichever you'd like, to see a 100% accurate way of sketching this. And there we have it. Very interesting shape. So I hope that gave you an insight into polynomial long division and sketching polynomials. Hope to see you in the next video. Best of luck.